So we have few more things to cover, and let us go to that. Now, if I have two functions, f of x and g of x, there are different ways of differentiating them. One is I can write them as a sum, d of f of x plus g of x, differentiating these two things with respect to dx, or I can write them as a product, f of x into g of x, then differentiating them by dx. Or I could put the g of x into f of x, put this g of x into f of x. So that is f of g of x. Now this third thing, we are not studying now because this comes in your class 12th portion. So we'll study that time, God willing, if I am teaching. So we'll cut that off. Okay. So sir, now you will ask me, sir, you talked about sum, you talked about product. What about subtraction? What about division? What about difference, quotient, and all? What about them? So I understand your concern, and therefore I'm writing it like this. Subtraction. You got it. But this thing I can write it also as like this. It's the same thing. So basically this is addition. Now, now you'll ask, so what about division? Let us solve that also. F of x by g of x, I can also write it as f of x into 1 by g of x. So this is basically multiplication. So in this video I will be focusing on these two things more. I will tell something about division at the end of the video, but mainly I'll be focusing on these two things, because if I can prove addition, differential of addition, subtraction is also valid. If I can prove differentiation of product, quotient is also valid. Okay, so let us go to study about differentiation of a sum of two functions. So students, here I want to show you how a sum rule works out. Okay, so this will be the question, and the question is x plus cos x. That will be our question. Okay, so the question is f of x, one function, is equal to the sum of two functions, x function and cos x function. So how do we differentiate? So it? So this is d by dx of this whole thing. How do we do it? So that is what we need to see. Okay, so let me take that off now. So imagine x plus cos x. Okay, so it has x function in it. It has cos x function also in it. So what is x plus cos x? It is this, this indigo violet line. Okay, curve, not line, curve. Look, that looks like a snake going around. Okay, anyways, so let me zoom in and take come at this point, 0.5. Okay, now how is the x plus sine x? That is, how is this? Let me take that off. Okay, so how is this graph made? X plus sine x, how is this graph made? That I would like to give a little more explanation on that. That will be, see, you have x and the distance of x. I'm considering everything at the point 0.5. Okay, so you have distance x here. Now, so let me mark that, and then you have the same distance from, this is a cos x function, so cos x also has a distance like this. Cos x also has a distance, and what you're doing is, I'm drawing it a little to the side so that you can see that. Okay, what is happening to this is, this function here is the sum of these two. That is, this big function, this big line is equal to the sum of the yellow line plus the purple line. You get it? So that is how the whole graph is made. The whole graph x plus sine x, you get it? So the x values plus the, sorry, x plus cos x. So what you do is you draw the cos x graph, you draw the cos x graph, and at each point of cos x you add the x, x values, and when you add the x values you see that the graph, that is why you see this curve in the graph. It's because it is dropping down, because the cos x is dropping down. See, you get it? So every point is the sum of x values and the cos x values. If that much is clear, now what do I mean then to find a differential? So to find a differential of this function means, let me choose another color. Okay, differential means a small change in input. What is the change in output? So I need to find this change in the output. That is what I need to find, right? For a small change in input, that is what I need to find. Okay, fine. So let me draw that line. This line I'll draw down and see what are the changes that are happening. And here also I will draw one line. This is the original line and this is the new line. Now let me take another color and let me show you something. Here in the x, this is the x graph, the straight line is the x graph. Here there is a small change happening. Can you see this change? Can you this change? There's a small change happening. Okay, so that, let me draw with this. And here if you look at this graph, that is, this is a cos x, this is a cos x graph, going like this. So there also you see a small change, but it's a decreasing change. See, do you see this change like this? So that also I will mark it like this. So what do you see? You see that this yellow change, this yellow change is actually the result of or because of the changes that happened here and the changes that happened here. So what do you see? What do you understand? That is the change, or let me write in another words, CH is my short form, okay, just to make you understand, just my short form, not an official one. Change in x plus cos x is equal to change in x function plus change in cos x function. Cos x, c with a small c. Okay, so now looking at that, we can understand what happens when a differential. So change, so the unit, the changes in output with respect to the changes in input are called differential. When the changes in input is almost zero, approaching zero, that is what differential is. So same way, d by dx of the differential is equal to d by dx of x plus d by dx of cos x. Okay, so what do you understand? The sum of, use this color, the differential of a sum function is the sum of its derivatives, each of its derivatives. Differential of a sum function is the sum of each of its derivatives. So this is kind of simple, I know. Now we will proceed on to a little more difficult stuffs.